Hi, so you've learned a little bit of maxima, minima, finding greatest and least values of functions, etc. Now, I'm going to share with you a situation where you have a function of several variables. Say there could be a function of three variables x, y, and z. And there is a constraint associated. That means xyz cannot take all possible values. Xyz can assume a limited set. That means there is a condition that will bind x, y, and z. So that's a constraint. There is a constraint on xyz, and you want to maximize or minimize. You want to maximize or minimize a certain function of, let's say, three variables x, y, and z. How would you do that? How would you do that? Let me share an example with you and tell you what one could really do. So here we have a function u, which is a cubed x square plus b cubed y square plus c cubed z square, right? Which is a function of xyz, right? And there is a limitation on xyz. Xyz are limited by this fact: 1 by x plus 1 by y plus 1 by z is 1, right? That's the limitation. That's a constraint. So this is my constraint. Subject to this constraint, I need to find the maximum or minimum value of this function. So what should be my values of x, y, and z so that I could maximize or minimize this function? Now, as far as for this function is concerned, look, I could have selected x as 1, y and z as infinity, and it will satisfy the constraint. So if x is 1 and y and z are infinity, this constraint is satisfied. And for x is 1 and y and z is infinity, you can assume an infinite value, a very large value. That means what we eventually get for this function is not the greatest value of this function, because this function can become infinite, right? Let's say for x equal to 1 and y and z infinity. What I'm seeking to do is then perhaps find values of x, y, and z that will minimize this function, that will make the function the smallest it could be. What we typically do is we take a linear combination of the function and the constraint. 1 by x plus 1 by y plus 1 by z minus 1 equal to 0. Let me take a linear combination. This expression is u, whose minimum in this case I need to find. So this is the auxiliary function that I construct, which is u minus lambda is only cosmetic. I could have taken plus lambda also, that's not an issue. Minus lambda, lambda is the parameter, 1 by x plus 1 by y plus 1 by z minus 1. And then I differentiate this function with respect to x partially, equated to 0, which gives me this 2a cubed x square x plus lambda by x square equal to 0. I differentiate this capital F with respect to y and equate it to 0. I differentiate it with respect to z and equate it to 0. And then I solve for x, y, z and lambda. These are the four unknowns. So what I do is, there are various ways. Depending on the algebra, there will be various ways of handling this. So I multiply this by x, I multiply this by x, and I multiply this by y, and I multiply this by z, so that I could get lambda by x plus lambda by y plus lambda by z, which anyways x by 1 by x plus 1 by y plus 1 by z is 1. So then on carrying out this manipulation, multiplying this by x, this by y, and this by z, and adding the 3, I get this twice a cubed x square plus, okay, so I've taken 2 common, plus b cube y square plus c cube z square plus lambda into 1 by x plus 1 by y plus 1 by z equal to 0. Now, what does it give me? 1 by x plus 1 by y plus 1 by z is anyways 1, because that's the reason I perform these manipulations. And this is the expression u. This is the expression u. That means lambda turns out to be minus 2u, as you can see, because this is 1. Now, once lambda is minus 2u, I plug in minus 2u here. So I get 2a cubed x minus 2u by x squared equal to 0. Similarly, lambda equal to minus 2u here. I get 2a cubed by y minus 2u by y squared equal to 0. Lambda equal to minus 2u here. I get 2c cubed z minus etc. and so on and so forth. So I get like the third equation, 2a cubed z minus 2u by z squared equal to 0, and so on and so forth. right? Now, what does it give me? What does it give me? Very clearly, do you see that 2a cubed x cubed is 2u? That means a cubed x cubed is u. So a cubed x cubed is u. Similarly, notice that a cubed z cubed is also u. So I'm sorry, this is b. So let me fix this. This is b. And so this is b and this is c. This is c. Right. So I get these three equations. And then what I do is I solve for xyz. When I solve for xyz, I get ax equal to by equal to cz, each is equal to k. X is k by a, y is k by b, z is k by c, and these are the values of x, y, z which when plugged into this, these are the values of x, y, z when plugged into this, that will result in minimizing this expression. That's the foundation that I want to build into you. It's extremely important, extremely critical to understand. I will give you more illustrations as we pass along on how we could minimize and maximize functions of several variables, right? This much for this time. Thank you.